Yeah, let's go through a few notes here. We've got kind of a new topic today, which is still based on the stuff we've been doing. It's just a different aspect, a different look to it. And it was something that I've been using, I just really haven't told you about it yet. Okay, so let's discuss the actual the new process today. So the big thing is we've been doing with polynomials, right? This is kind of our main topic for the last, so many weeks in here. We've been talking about polynomials. We've been talking about roots. Okay. Now roots, if you don't know, that's an x-intercept. It's where it's the x-axis. So that's kind of what they always call them. So x-intercepts. We've been dealing with different methods of finding them. We've done, if you could factor, we could do that. So we talked about factoring. If that was possible, I very vaguely hinted at the quadratic formula. We'll see that later. That's something we're going to wait till chapter 9 to really discuss again. But then we talked about this rational root theorem, where you look at the back number, you look at the front number, and you make every possible combination of roots, and you synthetic substitute them in, and you see which ones work, and all that good stuff. And eventually you'll find one or two that work, and then you can divide them out. We talked about the actual process of using that rational root theorem, where we discussed, either you synthetic sub to figure out which ones work, synthetic substitution, and once your calculator tells you 0, that's a root, and you go divide it out. Now the types of division that we've actually discussed, we've done long division and synthetic. Long division is I know this is weird. I prefer long division. I like it. It works for every type of polynomial. You don't have to do any weird rules to it. As opposed to synthetic, it only works in the very special types. Synthetic division. And that's the one that we were doing on this homework today. But I kind of vaguely ignored a topic. And it wasn't on purpose. It was just one of those things that it's nice to see how to do processes like this and how to work through things. But there's something you probably should know. It's how you can make a polynomial. You can make a polynomial a very specific type. So we can design a polynomial that will hit specific numbers. So for instance, and this is something I've kind of vaguely discussed. Let me bring up a graph here. Okay, I'm going to just bring up a graph real quick, just so we can discuss this. And this is where your Chromebook will come into play, and I'll show you what website I'd like you to go to. There's actually two that we're going to look at today. All right. There we go. That's what I wanted. Okay. So, let's say you have a business and you're kind of plotting your data for your business, right? And what you're looking at is you kind of have ups and downs, and that's how every business goes. You have really good months where you have really good sales. You have some bad months where maybe you have to buy product and you have to spend a lot of cash. And so your business could look something like this, right? Where you have some ups and downs, and then hopefully you kind of go up at some point and you kind of stay up there. I mean, it can keep oscillating back and forth, but the idea is what we've been discussing is these points right here. Okay, these points of intersection where it hits the x-axis, those are called the intercepts or the roots. Now, in common sense terms, that's where you broke out even. You didn't make profits, you didn't make any losses. You kind of hit 0, where you're just kind of balanced out. Maybe in the beginning of your business, you had to put a lot of investment into your business. So you had to put a lot of money in there. So you bought building, you bought all the products, you paid employees, and eventually you start making a little bit of money, and you break out of it, and you're like, yes, I'm starting to make a little bit of money, and then you start to go down because you have to buy more product. So you have to buy more product, and you're kind of down a little bit, and then you start making sales again, and it starts going up, and then you eventually figure out that you can optimize what products you buy from, who you buy it from, and eventually you just start making pure profit. That's kind of the goal of every business, right? Every business has to go through that. You just got to weather that storm, okay? whether you can survive those moments where you're kind of in the red for a little bit. That's why a lot of businesses have Black Friday coming up. I mean, think about it this way, and this should be a red flag to you. If you've been paying attention to shopping and businesses around here, you know, like Target and Walmart, when did they start Black Fridays this year? Now, beginning of November through the rest of November. That is a massive red flag to me. The reason being, they're saying that we cannot survive this year on one Black Friday day alone. Because Black Friday, they call it Black Friday because you're in the red, you're at a loss for the year, and one day of the year they lower all the prices and they get back to black, they get back to profits. Okay, that's what Black Friday is called. That's why they have a Black Friday. They have it once a year. Amazon kind of threw a kink in the plan. They kind of did a Prime Day. It's usually the middle of summer. They did it in October this year, beginning of the month. They do that. They have one day a year. They try to make a little bit of profit. This year, if you notice, every business is doing it for the full month of November. It's a huge red flag. That means they can't survive off of one day of sales. They need multiple days of sales because they're doing so poorly. So if I was investing in the stock market, I would not want to be with those companies right now. Just because I know what they're telling me and how soon they're starting a Black Friday. That's a massive red flag to me if I was an investor. Now it's good for us as consumers. We get a bunch of days of, where we can buy some stuff at cheaper prices. That's great. But also just as an investment opportunity, not great. And so this is kind of their idea, right? They have some ups and downs. This year is kind of a downer year because, they just haven't been open. They haven't been making the sales as much as they have, and people are in hardship. They don't have a lot of money anymore. So the idea is that it's still there, right? What I haven't discussed with you is that on all the problems we've done up to this point, I've designed every problem we've done in class. I haven't pulled them from the book. I've been making them as we go. And it's not difficult to make your own polynomial that meets certain requirements. And I want you to see this today. I want you to see how easy it is to make a polynomial that will hit your certain numbers the way that it does. Okay? And that's what I want you to experience. Something like this, where I'm hitting certain numbers. Okay? But I'm going to make it so that they look a little bit better. So somebody give me, somebody give me 3 x-intercepts, really nice clean numbers, no decimals. Just, they have to go from -12 up to 12. Give me any 3 numbers you want.
-4, -2, 3.
Okay, I heard 2.
7.
I heard -3, and then I heard 7. Okay, I'll go with that. So sorry if I ignored any of the others, sorry. I just needed 3. We can do as many as you want, but I'll just do 3 right now to prove my point. So this is -3. This is 2, and this was the 7, I believe. 2, 3, 4, 5, 6. Yeah, okay. So let's say this is my polynomial, and I want my polynomial to kind of look like this. Okay? All right. Something like that. I'll just kind of make it up. We can make that polynomial, like the function that will do that, by just knowing those 3 numbers. If I had a 4th number, that'd be even better. I can really zero this thing in so it looks perfect. But just having these 3 x-intercepts, I can make a polynomial that will hit all of those. So here's how you do it. Okay, I just need to know what are the parentheses that represent those roots. So what is the parenthesis that represents x, or what's the parenthesis that represents -3?
X plus 3.
Say it again.
X plus 3.
X plus 3. Okay. Does everyone see that? That's like the binomial that represents a -3. That's what you had to do in synthetic division and all that, right? What's the parenthesis that represents 2?
X minus 2.
Yeah. So it'd be x minus 2, right? It's always the opposite of that number inside that parenthesis. And the last one?
X minus 7.
X minus 7. Okay.
Oh,
That would be my 7 number, right? Make sense? Okay. Here's what I'd like you to do. I'd like you to go on your Chromebook right now and go to a website. The website that I'm going to have you go to is called Wolframalpha. Okay, Wolframalpha is a website that's owned by Microsoft.com. So it's owned by Microsoft, the computing company. They bought it years and years ago. This used to be owned by a company called Mathematica. It was a supercomputer that universities had access to do calculations for their math and science programs. Well, it was so successful that they've opened it up to the public, and anyone can type in any query into the supercomputer and it will spit out answers. It looks like a search engine. It's not. The way that you have to think of Wolframalpha, think of it like it's an encyclopedia, if you understand what that word is. An encyclopedia used to be a textbook that you could buy and you could put on your shelves at home, and it would just have information stored. It was like a living Google. You didn't need to go online. You could just look up that word that you were trying to find. It wasn't like a dictionary. It would actually give you the entire history of that object. Maybe it was an animal or a country. They would just kind of fill in some basic information in there. Well, that's what Wolframalpha does. It is a living encyclopedia that people add to. It's not a search engine. Search engines like Google and Bing and other websites, they would scour the internet and look for websites that have those keywords, and then they would just spit out websites at you. Those are kind of helpful, kind of nice, because sometimes you just run upon Joe Bob's website that's really terrible, but he had the right keywords, and you don't want to look at all of his stupid ads and what he has posted. But Wolframalpha organizes it, and it just displays the stuff you need. So here's what I like to do. Do you see the little search engine box in front of you? It's like, is it yellow and orange? I borrow this. Looks like that, right? Yeah. Okay. I want you to type in that into it. I want you to type in that. So parenthesis x plus 3, parenthesis x minus 2, parenthesis x minus 7, parenthesis. All the parentheses, no spaces in between, just keep them side by side by side by side, and then hit enter. It'll take a little bit of time to compute. Okay, there's a bunch of information it gave you, correct? It gave you a graph, it gives you other things, it gives you roots and other things. What I'm looking for is the polynomial that it represents. The polynomial that represents this thing. It's usually down the list, it's like about the third or fourth item. It's like x to the third plus something, and it's just this big string. I want to know that. So, Rhett, do you have it?
X to the third minus 6x squared minus 13x plus 42.
Plus 42. Okay, is that what everyone's getting? Okay, this is what I did when I was making all those problems for the last 2 weeks. I made my problem in such a way that I already knew the roots going into it, because that's what I did. I took the 3 roots I wanted to hit, I typed them in exactly how you're seeing it into Wolframalpha, and then when you guys got to class, I would just go, hey, this is the problem I want to do today. This is the one that I want to find roots for. Let's do that, you know, that basic test where the rational root theorem, where you take the back number and you divide by the front number. And we'll find out possible roots that this thing can have. Well, it was the factor of 42 over the factors of 1. The factors of 42 are 1 and 42. It's 2 and 21. It's 3 and, what would it be? 3 and, what are numbers that go into 42? 3. That's a 1. 14, 6 and 7. You guys get the idea, right? And eventually it was positive, negative, and so if you notice, they're all right here. These are the roots that I came up with. Okay? Now, here's what I also like to do. Open up a new tab. Keep that Wolframalpha open. That's great. That's a really nice website to have because it can give you polynomials really, really fast. Okay, the second website I like you to open, so your second tab, I like you to have the website Desmos. Desmos opened up. Desmos is a graphing program. It's pretty much becoming kind of the main name brand in graphing capabilities. If I was, in college, this would be the website I'd be using for all my math. This graphing program is pretty impressive and it's free. On the website, it's in green, correct? Okay, I'll let you guys type that. But it's in green and it'll say like start graphing at some point. You can type that in. I want you to type this in, but before you start typing it, you need to put like an equals y in front of it. Every graph needs 2 variables, so you'll have to have a y equals and then type in all of that stuff after it. Now to type in powers, you have to use a little up arrow key. It's above the number 6 in your keyboard. Sometimes they have a little like button configuration at the bottom of Desmos, or you can use a little caret, you can type in the powers. But I want you to type this in a Wolframalpha. Or not Wolframalpha, Desmos. Did it look something like my graph? Something like it, yeah. Real generically. It's probably not. Maybe the little bumps go up and down a little bit further than mine, quite a bit, I bet. And the best part is you can zoom. You can do like 2-finger swipes and zooms on it. You can zoom in, zoom out. But did it generically, did it look like this? Did it, the left side go down, the right side went up? It hit my 3 major x-axis numbers, my intercepts, my roots, and it was going up and down. Correct?
How do I make this work?
Say again.
I don't get how to make this work. I need to add an X.
There it is.
Thank you.
Oh. All right. Makes sense? Did you get kind of a graph? Now, I think your graphs went really high and really low, correct? But let's say I wanted to make my graph a little bit closer to mine, right? Because your graph goes really high, if you looked at that. I mean, that thing skyrocketed, like way up here and way down here. And when you like looked at your graph, you're like, I can't even see where it's turning around. That thing was so high in the air and so low. There's another thing you can do. You can design your polynomial in such a way that it will hit very specific x and y intercepts. So let's say I wanted to have my little problem here hit, let's say, the number 1 here. Maybe I wanted it to turn around really, really soon and hit the number 1 on the y-axis. Well, what's the coordinate that represents this dot? What coordinate represents that? 0, 1, okay? 0, 1. And that's the number that represents it, okay? So, what you can do is you can manipulate this thing in such a way that you can get that number out of it. You can get 0, 1 to get out of this problem. And so you can manipulate this. You'll still get the same x-intercepts and the same y-intercepts. Or whatever number you want to hit. Maybe you didn't want to hit 0, 1, maybe you want to hit like 2, 7 or whatever it is, or whatever numbers you want to hit. You can design this thing in such a way. So that's what I want to look at today. How do you design this problem in such a way that it will hit the specific number you want to hit, but still have those same x-intercepts? So that's what we're going to look at today. Now this is how you do it. This is going to seem a little weird. This is the part I'd like you to write down in your notes. I like you to write this down. Oh, parentheses in the wrong spot. Okay, I like you to write that down. This is the problem you guys just came up with. It's the one you just designed. The x to the third, 6x squared, 13x, and 42. And notice, yes, I put an a out front. A is a multiplier. It is a scalar multiplier. If you multiply something on this polynomial, it grows and shrinks it. That's what a scalar multiplier does. It affects they call them the transformation of it. It can grow and shrink the problem. So you can hit specific numbers. Well, what was the number I wanted to hit? I wanted to very specifically hit 0, 1, correct? So when you look at the coordinate I want to hit 0, 1. This is something I wanted to hit for sure. What does the 0 number represent? X's, okay? And this number represents the y numbers, okay? You can plug those numbers in. You can plug those numbers in and you can solve, right? You can plug the x's in, so plug in all these x's here, and then plug in your 1 over here and then solve. Now, 0, 1 isn't a great idea. It's not good to pick a y-intercept. So we can pick any number you want. So let's say instead of 0, 1, let's say I wanted to hit a different dot. It's kind of hard to manipulate a y-intercept. Maybe I want to hit this dot right here. Maybe I wanted to hit this specific spot right here. Y-intercepts aren't very good to manipulate. I'll explain that later, why it's not a good choice to do that. How you hit this dot? Well, I need to know the coordinate of it, just like what you guys did. So if I want to hit 1, 2, 3, 4, and go down -2, I want to hit 4, -2. Those are the numbers I would plug in. So if I want to hit 4, -2, I'm going to plug those numbers in. Okay? So I'm going to plug that in. So I'm going to plug in my 4 into all my x's, and I'm going to plug my 2 into my -2 into my y number. And what I'm going to do is I'm going to solve for a. So this is 4 to the third power, 6, this is 4 to the second, 13 times 4 plus 42. Okay, I'm going to plug in the numbers you want to pick. I'll show you how to do the Y-intercept later. That's going to be tomorrow's stuff. So I want to hit 4, -2 for sure. -2 is my Y, 4 is my X. So this is something you do off to the side on your paper, right? It's nice when Wolframalpha you can kind of check, and same with Desmos, you can check the graphs. 4 to the third power, that's 64. 4 to the second is 16. I take 16 times 6, it's 96. 13 times 4 is a 52, plus 42. Let me double check my math. I don't know if that's correct. Okay, and then I'm going to add and subtract these numbers across. So now, somebody with a calculator, please. Add and subtract these numbers straight across. What do we get? It's going to be a negative number, I can tell you that.
Negative 42.
-42 is that, yep. Makes sense to me. That's about right. Okay, now the last step I need to solve for a. So this number is being multiplied on a, the -42. So how do I get rid of the 42? Divide it. We're going to divide it over. So a will end up being 2 over 42, which ends up being 1 over 21. That's my a number, right? It's a positive. The negative signs canceled out. It's -2 divided by -42. And it's simplified to be a fraction, a decimal. Fine. So be it. So if I go back to my equation, and I just happen to put this in front of it, 1 over 21. It'll hit the dot I wanted it to hit. It'll go through my 3 x-intercepts correctly. It'll go through -3, 2, 7. And it will also hit 4, -2 perfectly on its process of doing ups and downs. It won't be a valley there. It will hit it though, for sure. I will make sure it does. So in Desmos, okay, you still have that one graph put in Desmos, correct? Okay, you still have that graph there, okay? You can go to the next line, go to because you can always pick the next graph you want to put. And I want you to type in this one, where you don't type in like this big monster of a thing. Just type in 1 over 21, make sure that's a fraction. You can do a little fraction key. Then put parentheses after it, put these 3, and then hit enter and show what it has. So you're going to type in that stuff where you put 1 over 21 in the front in Desmos. And did it hit your 3 x-intercepts correctly? Did it hit -3? Did it hit 2? Did it hit 7? And did it go through 4, -2? If you go find 4, -2. That's what I want you to check right now. Did it hit all 4 of those dots? Did?
Yeah.
Okay, nice. Now, that simple manipulations. I made a polynomial in such a way that it works. It hits the right numbers I wanted it to, and it even passed through a certain coordinate I wanted it to pass through. Okay? Now, there's other ways you can manipulate this. You don't have to go through any specific coordinate, right? You don't have to. I can change this in such a way that I can manipulate so I hit certain y-intercepts and I can hit other things. Y-intercept is probably the hardest thing to change because you do actually change where the graph hits when you do that. So y-intercept is a little bit different. It's a very simple number to plug in there, but it does change your x-intercepts because you could actually shift off the x-intercepts. The y-intercept is the one number I probably shouldn't have picked to try to change because it won't hit the 3, -2, and 7. or negative 3 to 2 the 7. Okay, questions? Okay, that's what we're going to be looking at tomorrow. The goal is I'm going to give you some problems tomorrow where you have to make the polynomial in such a way that it'll hit the numbers I provide you. So you have to hit, certain x-intercepts. You have to hit a certain value out of that thing. You have to pass through, 4, -2 or something. And we're also going to make it in such a way where we can have imaginaries, where maybe you don't have to hit the x-axis a couple times. I want it to oscillate up in the air and hit certain values up there. So that's what we're going to look at. Okay? All right, questions at all about what we're going to be doing the next couple days in here? Okay, we have homework due today. That was your page 324. I'm going to give you the rest of the time today, which is about 10 minutes, sorry, to work on that if you have not finished it, because it is due today. Okay, question? Yeah, so you can borrow mine if you want. Yep.